Hey everyone, Will from Runchat here. In this tutorial we're going to look at some of the different control net models for use in conjunction with both SDXL LoRa's for generating images with a particular style or subject, or Flux LoRa's. So we're going to start from scratch and make sure that you've already completed the last tutorial which shows you how to make Flux and SDXL LoRa's. That'll be useful for this next task. So I like to start by just making a building by Gary as my form, and we're then going to use control nets to try to generate new images with the same form as our reference image. Now we can use control nets with images that we generate or with screenshots from CAD software and things like that. That's particularly useful if you want to stylize multiple views of the same object so that you can get consistent images of a single object instead of just hallucinating different images over and over again. But for now, we're just going to try and produce this shape in a few different styles. So let's have a look at the control net models that we have. So if we type in control, there's a bunch which installed by default with Runchat, and if you've linked a file account you can always go ahead and install more. And the one that we're particularly interested in for today is the SDXL control net in Paint. So the advantage of this model is that it will apply a control net and a mask, so it's only going to generate or regenerate our object here. And that can be really helpful for differentiating this object from the background, because there's a bit of a tendency sometimes for these control net models to kind of blur the foreground and background. But let's have a look at a few of these and just compare them quickly and just go through the different strengths and weaknesses of each of the models. So to start off with, let's have a look at the Flux Dev Depth Control Net. This model has a depth preprocessor in it, which means that you can just plug in any old image and it'll work out the depth for you. And we can do things like run a prompt. We have no LoRa, and we would expect to get something which is kind of in the shape of this building, but made out of toys. Okay, and generally speaking, we will get better outputs if the aspect ratio of our input image and our generated image, or the image which we use for the control nets, are the same. So this is a square image. I'm going to use a square image with this test model. Okay, there we go. That does loosely look like it's made out of toys. We don't have very much control over exactly what made out of toys means. That's one of the advantages of using a LoRa model. Okay, so let's add a LoRa. And let's use this Art Nouveau interior model. When we select it, it copies the trigger word into the prompt, and we'll run that. So this is a model that was trained on images of Art Nouveau interiors, building interiors, and so now we would expect that we're going to get a building interior which also has this kind of form. Okay, what we can see here is that the model is only fairly loosely applying our LoRa to this building form. So we could try telling it that it's an interior, which is going to push it closer to the kinds of images that this was trained on, and I would suspect we get better outputs, which we do. So as a general rule of thumb, when you're working with LoRa's, you will get better results if you're generating images which are kind of intentionally similar to the images that you fine-tuned the LoRa on. So we fine-tuned it on images of Art Nouveau interiors. If we try and generate a building exterior, the model's generally going to struggle with that more than if we use it to make more interior models. So if you want to make exterior shots, train LoRa's on exterior images is a pretty good rule of thumb. Okay, so that's working pretty well. We can try some other LoRa's. I think there's a toy one which we tried before with the demo. So this LoRa was fine-tuned on a bunch of images of toys on neutral white backgrounds, which means it's pretty good at differentiating foreground and background. You can see though that that prompt has thrown it out. Let's get rid of building exterior. Okay. That's way better. Now we've got all of the kind of body parts of those toys making up that building. So this is a pretty good model. The only issue with this model really is that it's only going to, it's not perfect at following your depth. There's kind of some slight differences here. So for instance, if we had a model which had like a big, or a reference image that had a big hole in it, let's say, or a really super specific silhouette that we wanted this to follow exactly, this model, this flux control depth model, it's kind of a little bit more loosey-goosey than that. So it uses the depth, but it's not completely constrained by the form of the depth, which makes it great for creative exploration like this, but less good if you're wanting to force a model into a very specific shape. Let's have a look at the canny LoRa, and we'll run that one as well. Let's try it with our toys. This has set it back to landscape. We want that to be square, but we'll run it initially. So this one also has a preprocessor, I think. Let's put it on square. I'm pretty sure that it does. Though maybe not, actually. I'm going to turn off the safety checker. I can't remember if this has got a preprocessor. So we have a canny filter in Runchat, so we can essentially go and create a image which extracts the edges from our photograph, and we can try using that. Okay, this is a fairly good example of maybe over constraining the control net to these edges. So because we're forcing it to follow exactly all of these lines, it's not able to be as creative in how it's working with the toy geometry from the LoRa. So we're going to turn down the control LoRa strength quite a bit, and we'll run that one again. Okay, maybe that's turned it down a little bit too much because we've lost the building, so let's try somewhere in between the two. And we can probably increase it just a tad more. These numbers do tend to end up being really susceptible to small differences. Okay, so now we've got definite building. So somewhere in between those seems like the sweet spot. But because we have to turn down this strength, that means that it's also going to start affecting this silhouette. So it's going to loosely follow these edges. There we go, that was the perfect amount, I think. But be pretty creative around that, which is what you're seeing here. So because we've stopped controlling it as much, because otherwise we just end up with kind of a copy of that shape exactly, and we want to give it some creative freedom, that's then pushing it into a space where we can no longer control the silhouette once again. So let's have a look at some other models for Flux still. So we've talked about the canny control net, which is edges, and we need to generate our edges before we use that one. The control LoRa depth model, which just lets us use an image and a preprocessor if we want to. And then the last one that we have is a general endpoint, where we can throw in this has to be a processed image, and choose our LoRa. And we make sure we're using the same aspect ratio. And this one, the advantage of this one is we just have a couple of different options for how we're going to control the image. So we have depth, canny, pose, just a grayscale image and a normal map, as well as a strength slider for how strong that the control is. So let's run that one as well. In terms of credit costs, this general model is more expensive than, so it's twice the credits than these canny and depth models alone. So if you can get away with just using the canny or depth models, go for it. This one gives you a few more options. It's also much slower. So there is a option here for the threshold of the control image, so we can basically threshold out high or low values from our mask. In some cases that can be useful as well. So you can see this takes much longer than the edge net. Works a little bit differently. You can see it is trying to generate some toys, I think, in there within the building. That edge strength is too high, so we would be turning that down. Actually, I've got it on depth. That's my problem there. So I'd want to choose the right control net type. I guess we might as well show depth. So we need to do depth pre-processing for this, which just means we have to generate a depth image instead of plugging in our photo. And then we can leave that on depth and probably leave it on 0.62 or so and run that. So we'd hope it would end up looking pretty similar to the depth LoRa model we used before. Under the hood, these models, or these two models, they're actually using different control net techniques. So the canny and depth, they're called LoRa models. They're fine-tuned for producing controlled images, whereas this model here is using a different control net technique, which should actually follow the edge and depth maps a little bit better. But it is a lot slower. So that's Flux. So you can see that one is following the silhouette much tighter than our previous one, which was much more creative in the silhouette. It's also following the depth map more tightly. So generally speaking, this model is going to have a kind of a closer relationship to the form of your reference image, which in some cases is what you want, with less creative freedom. You can always give it more creative freedom just by turning the strength of that control net down. So we're going to run that while we do the next demo. Okay, the other model that we supports control nets is SDXL. So SDXL is generally speaking a much cheaper model, especially just for generating images, not for using control nets. So for in-painting or creating images with fine-tuned LoRa's or just creating images, it's extremely cheap. So we're going to drop one down, have a look at our options that we've got here. We've got some sculptures, we've got a toy style SDXL, let's try that one. So this model is fine-tuned just to make everything look like piles of toys. Slightly different to these Freya Jobin ones. Okay, there we go, we've turned that down too much and it's not following our depth map at all. So again, we'd have to find that balance between the two. So for SDXL, we can also use this with a control net. So let's say we want to make this out of a pile of toys using this demo model. We've got a couple of options. We've got control nets with LoRa's and we've got control net in paint. So there's only two options with SDXL. Let's have a look at the first one. Plug this in, check out our options. It also lets us choose between depth or canny, and we have to provide a pre-processed image. So we're going to take our depth map, and we're going to use that. Whoops, I plugged it into the wrong thing there. And we'll pick our toy LoRa, plug that in, and hit go. A little bit like the Flux one, it takes a while to run. It's pretty slow. And so while that's running, we'll compare it to the other one. So that's the SDXL control net in paint. Got a few more options. So we've got a mask URL, an image URL, a control image URL. So I'm going to use this control image URL here. We need a mask URL, so we need basically just the pixels of this object and not the background. And we also need a base image URL. So our base image, we can just use that guy. And we just need to generate a mask. Oh, there we go, that's finished making our building out of toys. It's not too bad, that one is pretty good actually for SDXL. And it's done a pretty good job of matching the silhouette actually, compared to Flux. It's a lot closer with the silhouette. Okay, so how do we generate our mask? There are some tools for working with masks in Runchat. We've got cutout mask, composite image, painting mask, and we can also generate a mask often by using our mask image tool and just saying what we want. So we're going to pick the building, and hopefully that'll mask out just the building and forget about everything else. Now this mask here, when we provide this mask, our control net is going to be forced to follow that mask exactly. So that means this mask's got kind of a few little pixelated areas in it. It's not actually the neatest mask ever. We'll see how that works, but it's going to mean that our control net is only applied where this is white and it won't be applied where it's black. Alright, and we're going to pick our toy LoRa and plug that in, and we'll just hit go to see how we go. So in this case, our LoRa has actually done a pretty good job of differentiating the object from the background. In fact, with most of these demos that I've done, the object has been well picked out from the background. But that definitely doesn't always happen. We've got to tune that model a bit more, obviously. Let's try using a different LoRa model. Let's try, let's try this one. And we've got to set this guy up. We'll pick a different LoRa model as well. Okay, so there's a few things to set up here. We've got our noise strength. So that's the issue that we have now. So our input image is only getting a little bit of noise added to it. So I'm going to set that to 1. So we're completely denoising our input image, and we'll leave our control strength where it is, and we'll leave this on depth and rerun it. Okay, so that's our shell style LoRa. It's also done not such a terrible job of picking this out from the background. We're starting to get a little bit of blur. And we'll see if the mask does any better. And the reason that we normally get this kind of blurring with the background is if you've got a LoRa which is trained on images which are full bleed, it's really going to want to full bleed the result. So here we go, here's with our mask. You can kind of see how it's just clipped that completely out from the background of the image, and it's kept the rest of the context. If we don't really care about the rest of the context, we could use a different input image here. Like instead of using our photo, we could use our depth image. All right, I'm going to try another LoRa. Let's try this one. And we'll try it with our other one as well. Okay, it's a bit better. I think we're going to see the difference between these two now. So you can see how this one's masked into the depth map. We've still got our underlying image, in this case the depth map, and we've only regenerated this area. And this is what we get when we don't have the mask. So with the mask, we're able to control the silhouette of what gets generated. So the generated pattern is relating to the silhouette of our depth map. Without the mask, that pattern it responds to our depth map for sure, this all looks pretty similar, but it starts bleeding into the background around the edge and in the foreground. And that's because this particular LoRa model is trained on images which are like pretty flat, pretty pattern-like, pretty full bleed. And so it's reproducing those same styles, even though we want to pull it out as an object against a background. So if you need to do that, you need to pull out an object against a background and you want your control net to respect a forced silhouette, then you need to use this SDXL mask tool to do that. And you can do it in conjunction with some other models, because remember, we can provide an input image here. So we could do things like using Flux, let's say, to create some kind of more creative content, and then use that as our input image and just turn down the strength of that image so we can recreate it a little bit using this SDXL LoRa process. Alright, so that's the relative differences between these control net models. They're all well suited to different tasks. Some are fast, lower cost, others give you a bit more control. Some work with SDXL, some work with Flux. And you often want to try a few of them to see what works best for your use case.